Question 2 says we should evaluate the integral x multiplying exponential x with respect to x. Now, before we start solving, notice that we have two different functions multiplying each other. We have the x multiplying exponential x. This type of integral is not one we can solve by applying the ordinary power rule directly. That won't work. So we use a method called integration by parts. Integration by parts. So that's the method we're going to be using for this problem. Now, integration by parts is especially useful when we are integrating a product of two functions. The formula we use for this is, the formula for integration by part is the integral of u dv equals u multiplying v minus integral of v du. This is the formula for integration by parts. Now we need to decide which part of this expression will be u and which part will be dv. That's what we want to figure out. For this question, we choose u to be for x, and then we have dv for exponential x dx. Now we choose this u equals x because differentiating x makes it simpler. Okay, so let's take the derivative of x. If we do that, remember the derivative of this u with respect to x is equals 1. So what next? Let's cross multiply this. Of course, we have this to be du equals dx times 1 will be dx. Let's leave it here. Because we have du here, we have to find this du. Does that make sense? Okay, on this dv, for us to be able to get this v, we have to take the integral of both sides. Integral of dv, apply that integral sign to both sides. So, of course, if you take the integral of 1 with respect to dv, the answer will just be v. Okay, so which will be equals integration of exponential x will still remain exponential x. And when you do this, you're done with it. But don't forget that what you need to do finally is to plug in everything you've gotten into the formula for integration by parts. And how are you going to achieve this? It's pretty simple. Now we have the formula already. Integral of what's your u? You know your u to be your x. X. What's your dv? Your dv is, where do we have it? Your dv is exponential x dx equals, then on this part, u times v. This is your u, x, multiplied by v, which is exponential x, minus the integral of what's your v? Your v is exponential x, multiplied by du. What's your du? This is it, dx. Now, what's the next line? It's pretty simple. So, this left-hand side, integral of x exponential x dx equals, we still repeat this x exponential x because they are just multiplying. On this part, we have to take the integral of exponential x again. Remember, the integral of exponential x is still exponential x. But this time, there is no integral sign. You just have to add plus c, which is constant of integration. Remember, these are indefinite integral. This left-hand side is the original function given to you to integrate. So we still repeat it for the last time. Integral of x multiplied by exponential x dx would be equals, I'm saying that exponential x is common to both sides. What I mean is that I'm seeing exponential x over here and also here. So because they are common, I'll have to factor it out. Then immediately I pull that exponential x out there. What will be left here is x. If I pull it out on this second term, it's just 1 that will be left, right? Plus this c, the constant of integration. And this appears to be the final problem. This appears to be the final result to this function you're asked to integrate. The key idea in this question is that when we see products like x multiplying exponential x, we can use integration by parts, choosing the part that becomes simpler when differentiated as u, and that takes part of question 2. Let's move to question 3 real quick.